location of a point. Sometimes we are interested that whether a point lies inside the parabola, on the parabola, or outside the parabola. The concept here is same as what we have done in the chapter of circle. That means in chapter of circles we have seen that if S1 is less than 0, point is inside the curve, S1 is equal to 0, point satisfy the curve, and if S1 is greater than 0, point is outside the curve. So similarly in this, S is the equation of the curve given. Whatever curve is given is the equation of curve. S1 is obtained by replacing coefficients of xy with the coordinates of the point. So first thing is if S1 is greater than 0, point is outside. If S1 is equal to 0, point is on the curve. And if S1 is less than 0, point is inside the curve. These three cases will be there. For example, if I take y square is equal to 8x, any curve is there. Now in this case we can take different situations. For example, case 1, point A. Suppose I want to check point A is inside or outside. Point A is S. Here S will be y square minus 8x. This will be S, my equation of the curve. So now I will check whether the point lies inside the curve. So any point I am taking, for example, 6, 1. So the moment I put here S1, in this case S1, x is 6, y is 1. So 1 minus 6 into 8, 48. X is 6, 6 into 8, 48 is equal to minus 47, less than 0. That means this point must lie inside the curve. If I put S, another point B, for example, 2, 4. So first I have to check whether it's satisfied or not. So S1, in this case S1 will be y is equal to 4, 4 square 16, minus 8 into 2, 16 is equal to 0. So this point lies on the curve. Second point, similarly you can take any other point, for example 2, 8. So if you observe here 8 square, in this case S1 is, or you can say SB and this is SC, put y is equal to 8, 64 minus 16. So this point is outside. So I want to check the relative position of the points. It will be of this type. Point A is inside. Inside means between these two walls, inside here. So this portion is known as inside. Here S1 is less than 0. Here if it is on the curve, S1 is equal to 0. If it is outside, S1 must be greater than 0. So I can say that point A, for point A I got one condition that S1 is less than 0. So point A is somewhere here, anywhere it can be, 6, 1, 6, 1. So for example, point A is here. Point B, I can say this is the point B, which is on the curve satisfying. And point C is somewhere here outside. C is here. So in this way I can identify the location of the curve. This is one point. Second comes parametric equation of the curve. Parametric equations. Or parabola. So immediately question arises, what is this parameter? That means I am now connecting x and y, two different things, with the help of some third variable. So x and y are connected with the help of third variable. For example, I can say x is a function of t, y is a function of t. Then t becomes the parameter. T can have any real number. So instead of now selecting two variables, I have to select only value of t. X and y automatically gets connected. For example, if I see for the curve, first I am discussing y square is equal to 4ax. if I take x is equal to at square and y is equal to 2at, where t can be any real number, so t is the parameter. That means if I eliminate from this 2, I will get this equation. So t is the parameter. For elimination, either I can put t is equal to y upon 2a in this equation or square this. So if you square the second equation, I will get y square is equal to, squaring second equation. So y square is equal to 4a square t square, squaring this. Now t square is how much? X upon a. So 4a square and t square is x upon a. So what I am doing? Eliminating t. T. What is t? Parameter. Don't think that t only have to be parameter. It can be theta, it can be lambda, it can be p, it can be any variable. So that particular variable I have to eliminate to get the original equation of the parameter. So in this case, I will get y square is equal to 4ax. This is the equation of parabola. That means on this parabola, I can say that point T is at square, comma 2at. If I say mention point T, this is the point. But if I say that parametric equation, then parametric equation is x is equal to at square, y is equal to 2at. This is the parametric equation of the parabola. So now question arises, what is the parametric equation when we are considering the parabola in different forms? We have seen different forms, y square is equal to 4ax, y square is equal to minus 4ax, x square is equal to 4ay, and x square is equal to minus 4ay. So for all those forms, for example, y square is equal to minus 4ax. Parametric equation is x is equal to minus at square and y is equal to 2at. This is the parametric equation for this. Similarly, if I have x square is equal to 4ay. In this case, as you can see, x and y are interchanging. So just I will interchange. So here this parametric equation will be x and y will interchange. X is equal to 2at, y is equal to at square. So x is equal to 2at and y is equal to at square. This will be parametric equation. Similarly, third case, if I take x square is equal to minus 4ay. In this case, parametric equation will be, now in this case, y, this x and y will interchange. So x is equal to 2at and y will be how much? This will go to x and x will go to y. Y is equal to minus at square. This will become parametric equation of this curve. If center is not 0, 0, center is something, x minus h, we will replace here x minus h, we will replace here y plus k or y minus k. So with the center also we can replace. So this is the equation of parametric equations of parabola.